Hello dear colleagues, now I'm going to show you the principle of the so-called ring precipitation test. Precipitation is an immune reaction between antigen and antibody, quite similar to agglutination, the only difference being that the antigens, in this case called precipitogens, are not a part of a larger structure, so they are not part of the bacterial cell, but they are just some, let's say, protein molecules that are in solution, so soluble molecules. So the antigen-antibody complexes are only molecular complexes without cells inside. Otherwise, it's just the same. Both agglutination and precipitation require electrolytes in order for the complexes to be stable. So we can see a visible reaction only in the presence of electrolytes. So these reactions cannot happen in distilled water. Now, what's the principle? We need to mix a serum which contains antibodies, like precipitants, which is usually our region, and we search for antigens in a clinical specimen, let's say in a type of tissue or a type of organ, whatever. So, first we add the serum on the bottom of the tube. Serum is initially heated up to 56 centigrade degrees in order to inhibit some naturally precipitating substances in the serum. And then, very carefully, we need to add the antigen-containing solution in order to observe whether will be antigen or not. Very carefully, just drop by drop, sliding on the interior surface of the wall. Both liquids should not mix to a great extent. As precipitin is more dense, it will stay on the bottom. Precipitogen will stay on the top, and here on the border between them, there will be a reaction and precipitates will be formed, so we will see a milky white cloudy precipitation ring. This is a positive reaction. I will perform also a negative control where will be a precipitin and saline, as saline doesn't have antigens, so there will be no precipitation ring. Let's see. This is the precipitin. Okay, here's where I will perform the reaction. I will use the pipette to take some quantity. Well, I didn't write how much of the precipitin and precipitogen will we need. It's not so important, the volume. It's important to be equal. So this is the precipitin. Then I'll take the clinical specimen, which probably contains the precipitogen. Usually the more quantity, the more volume we use, the more difficult it is to perform the reaction properly. So here we need to be very careful. Just drop by drop, slowly. If you look closely, you will see that milky white ring in the middle of the tube. The more we shake the tube, or the wider the tube is, it becomes more difficult to see it. And now the negative control. Negative control will contain precipitin, And then this is saline. Carefully, drop by drop, alongside the wall. Let's see now. The negative control is perfectly clear. No sign of precipitation. Okay, let's compare these. You see the positive reaction and the negative control. Okay, so this reaction is not very much used in the practice, as precipitation usually is not so specific. However, it was very much used in the past to detect some extremely dangerous diseases like anthrax, for example. Just nowadays the reaction has been widely replaced by more specific and more precise methods. But as you see, it's one of the reactions that happens almost immediately, just for several seconds. Okay, thank you for your attention.